We're UMN Energy Club from the University of Minnesota Twin Cities, and we're here to discuss our solution to Gobain's challenge for next generation residential construction.
Cross-laminated timber, or CLT, is an engineered wood product made by stacking and gluing several layers of dimensional lumber in a perpendicular fashion. The cross-lamination results in high strength and dimensional stability. Because of its structural properties, CLT can be used as a sustainable alternative to concrete and steel in both residential and commercial buildings.
CLT is great for design. CLT is very flexible and it can be combined with other materials for even more flexibility with design. By adding more layers, the thickness can be increased and the panels can be very long. The material is structured in 3 axes, again allowing for more design flexibility. The warm color of wood has a positive effect on health and has been found to lower stress and increase concentration. Finally, an added bonus to CLT is that it has been tested during seismic activity and the damage was negligible. All of these reasons make CLT very appealing to homeowners.
One advantage that cross-laminated timber has over other building materials is how little it weighs. This, combined with the fact that it is versatile enough to be combined with other structural components, such as traditional wooden beams, allows for an easy incorporation into just about any house. Beyond this, the precise design of each panel allows for the pieces to fit together tightly when assembled, thereby increasing the thermodynamic capabilities of the whole structure. In terms of overall insulation, CLT's natural thickness allows for very little airflow and natural fire resistance. This means that temperatures can be maintained with about 1/3 of the total energy that a traditional structure would require. Perhaps most importantly, the CLT sequesters carbon and results in far fewer emissions than the production of steel and concrete. Looking at an example cross-section of a structure that uses cross-laminated timber, it is apparent that Gobain has the potential to manufacture every component. Additionally, with the replacement of a more environmentally friendly insulator, such as cellulose insulation, the whole structure becomes wood-based, all the while maintaining heavy load capabilities and fire resistance.
CLT is manufactured by harvesting, debarking, preparing, and then inspecting logs. Once they've been prepared and cut into manageable segments, they're grouped, planed, or sanded, and then joined into longer segments. Those segments are then glued, stacked, and pressed into alternating layers. That product is then cut into very tight tolerances. CLT manufacturing waste can be repurposed. For example, the bark can be turned into compost or mulch, and wood scraps can be turned into other wood products like oriented strand board or medium density fiber board. In addition to CLT, cellulose insulation can be used, as Nolan mentioned. Making cellulose insulation can accept paper, newspaper, and other kind of wood waste, and you fiberize the scraps into fine fibers and then treat them, typically with boric acid, which confers mold and insect resistance. It's virtually non-toxic to bird and aquatic life. It's relatively non-toxic to many beneficial insects. Although if it becomes waterborne, it can become problematic as an herbicide, and so cellulose insulation should be contained on a construction or deconstruction site. Cellulose insulation is easily reusable if there's no significant damage to the product. As can be seen from this demonstration, under 20 minutes under a heat lamp, cellulose maintains its ambient temperature of around 70 degrees Fahrenheit, whereas fiberglass is heated up already to around 81 degrees Fahrenheit. And this is because cellulose is excellent at resisting heat and fire, as you can see from its higher R value per inch, which describes its heat flow resistance. So overall, this means that cellulose insulation will lower utility costs to homeowners.
When it is time to install the CLT panels in the house, contractors are able to work at an extremely fast pace, all the while producing minimal waste. There is no need for on-site cutting, as all the cutouts for things such as windows and doors will have already been made at the milling facility. Just as with any structural beam, the installation requires little more than a crane to hoist the panels into place and traditional carpentry tools. All things considered, CLT makes job sites less cluttered and less wasteful.
When it comes to disassembly, there are 2 main forms that are odds with each other. There's demolition, which is cheaper but it's less environmentally friendly, and there's deconstruction, which is dismantling a building so that the materials can be reused or recycled. This is more environmentally friendly, but also more expensive. However, the cost of deconstruction scales with the weight of the materials being deconstructed. Heavier materials are more expensive to deconstruct than lighter materials. When it comes to CLT and its low weight, you don't have to make a choice, as deconstruction of CLT is both more environmentally friendly and cheaper. For cellulose insulation, it can be used instead of hazardous materials like asbestos, which decreases the risk and cost of deconstruction projects.
CLT and cellulose are very sustainable, which makes them very appealing. Since they can be made out of recycled wood and do not require fossil fuels to make, they are considered a green and sustainable product. They also sequester carbon, which allows for wood to be used in a more positive way rather than being burned and releasing carbon dioxide. Cellulose insulation specifically is very sustainable as it requires less energy for manufacturing and for home temperature control than other insulation. Being able to deconstruct instead of demolish is not only great for the environment, but also for people. By deconstructing instead of demolishing, less waste is produced, and therefore there are less hazards to local communities, and those communities are healthier for it.
Okay, thank you very much.
Thank you so much.
So I have a question. I mean, it looks like from my point of view, CLT's pretty well known. It's being used in some industries. Why, and you know, you've given a lot of reasons why it's so great, but what barriers do you see for its adoption? And how do you think you could overcome those?
I think that the main barrier for its adoption currently is just the fact that the primary market for it right now is overseas, mostly in Europe. However, we've seen in recent years, a lot of the market for CLT has been starting to move its way over to North America. So I think that in time, a lot of the barriers that it's currently facing, just being with its accessibility domestically, I think that in the next probably decade, a lot of those barriers will probably be overcome.
I'd also like to add that sustainable forest management is also a big issue in this area. So having, you know, a consistent rotation of resources, that they have the right sources of wood and that they're healthy enough and have grown long enough in order to be able to harvest. Since so much of silviculture is used for paper production and other lumber production, that specifically for CLT, that market, like Nolan mentioned, doesn't quite exist in North America just yet.
I'm curious what types of homes you're proposing, right? I'm wondering, so why the jump to CLT over maybe standard dimensional lumber, maybe?
Well, for CLT, like we mentioned, one of the primary benefits of it is that it produces very little waste, and it has a, when you look at the life cycle analysis of wood compared to things like steel and concrete too, it has a much smaller carbon footprint. So when you compare it with just wooden frames for houses, however, it's got a lot more structural capabilities than those do. It's way more fire resistant and has better seismic resistance too. And the installation process itself is a lot faster and easier. So just all things considered, CLT is a lot less wasteful than using like the traditional lumber that you would on a job site, because you're not having to make the cuts and edits to the wood that you usually would, that would cause all of this waste to come up, because all of the panels are made before they come to the job site. So it's basically like putting puzzle pieces together once they actually arrive to the building site.
Additionally, because of the cross-laminated structure, that the CLT in, you know, variations in humidity doesn't flex as much as unpredictably as standard cut wood lumber will. So depending on whether you cut in the transverse direction or the longitudinal direction, the way that the wood bends under humidity can be drastically different. So CLT helps to overcome that problem. And also because it's laminated, it also confers much higher strength properties than standard wood. So they can be reused for longer. They have generally a longer lifetime as well.
Thank you.
I'm curious to learn more about, I guess, why it was important for you guys to make the comparison between fiberglass and cellulose, and what it is about the, product that you thought was important to highlight.
So in part because cellulose comes from bio-based resources, so it can be made from recycled wood products or from the same sorts of products that CLT would be made from. So whatever scraps are left over, you could take those and turn them into cellulose insulation. So you don't need to find a different primary source for that resource. In addition, fiberglass, obviously, it's made from silicon dioxide from glass. And so recycling of that kind of material post-use is much more difficult than with cellulose. With cellulose, you can grind it up. Obviously, it only has a certain useful lifetime, just in the same way you can only recycle paper between 6 and 7 times before the fibers become too short to be useful. But it has a much longer useful lifetime and is therefore degradable. And there are ways to extract the boric acid from it before it's released or discharged. So in general, it's just a more environmentally friendly. It can become a more cost-effective option because you're recycling much more material.
Awesome, thank you.
And I could also note that it's got better insulation properties depending on how you manufacture and how you pack it. You get a higher R value. So it really ultimately will save more utilities to the homeowner in the same amount of space.
This is just a side comment, but I would be very interested to see the references to that information.
Sure.
All right, I think that is about time. But thank you very much for your presentation.
Yes, thank you guys.
Thank you.
Thank you.